We are live. Not that we're set up and ready to go, but we're
But at least we're
live.
live.
Yeah.
Hooray.
Oh,
Hi,
geez.
everybody. Do you remember when I used to say hi to everybody? Good times.
Yeah, yeah.
I'm going to do that. I'm going to do that again. So say hi to me. If you're like watching and you're in the chat, say hi. And then I will try to remember to say hello to everybody in a
If
second
you're
here.
in the YouTube chat, if you're in the Twitch chat, I'll say hello to you. So I'm going to say hello to Lord Gorjax and hello to Keeper of Maps, who says hi to F. Cain.
I hate to do this to you, Zapfen, but you just got promoted.
Is he now a mod?
Yeah. Yeah. There you go. Zapfen's a mod on my channel, and I
Yeah,
figured
yeah.
like how could I not
No, that makes total sense. Yeah.
voluntold Zapfan? No, you don't. There's no responsibility, Zapfan. There's plenty of other moderators here. We may
Hello,
even have more
Ian.
moderators than we have viewers.
That has happened more than once. So I had a
Oh,
horrifying discovery over the weekend.
yeah.
So I was cleaning the house and afterwards just felt like dog shit. Like a sick dog's dog shit.
Right.
And
So something you're allergic to.
it turns out that brick mortar contains latex. And so when I'm cleaning in the basement, all of the dust coming off of the bricks, because it's our house is like 130 years old,
Oh
and
no.
and so we knew that we needed to get the bricks what's called tuck and pointed. I think I said that right, or tucked and pointed. I'm not really sure. I'm not a brick expert, but we knew we needed to do this because the mortar was crumbling. And now I just need to accelerate when we get that done so that I can seal the bricks and stop having allergic reactions when I clean the basement. So my face is swollen, my hands are swollen, and this is like week 3 of this. But
Oh.
now I know. So knowing is half the battle.
Oh, that's madness. All right.
Yeah. Yeah.
I'm gonna say hi. Hello to Alan Gross, Albert VDS, Ambius, Gordon Dewitt, Henrik Bo Anderson, Ian Farquharan, Jessica.
Hello, Keeper. Gorjax. Hello, Ian. We have a smaller crowd over there. I'd like to say it's
Oh,
great to see
it says our
Jessica back.
stream. Oh, there we go. Okay. All right.
It
It
glitched.
said our stream went offline for a second there.
I don't know why.
So did it glitch for people? Let me know. Sorry, you were saying hello to people.
Oh, I was just saying it's great to see Jessica back. Jessica was super engaged in the CosmoQuest community back witch mapping project a while back, and it's great to see her here.
So it says you're not receiving enough video to maintain smooth streaming. As such, visitors will experience buffering. So have you got some what have you got a limit
No,
on how much on the speed that you're putting out content at?
no. Let me see what we're set to. Uh, output settings. Yeah. I know it's in progress. So it's going out at 30 frames per second, 1080. Is that the problem?
Well, but it should be the total bandwidth that you're setting aside for it.
No, like the only thing happening on my computer is monitoring the
So in the output
comments.
settings of Wirecast, you don't have a way to choose the amount of data. Like
No,
in OBS, I have it set for 7,000 kilobits per second is my output stream.
no, I don't have a way to do that. Let me run a speed test and see if something has hosed my internet. I wonder if I'm accidentally on wireless because I tripped over the Ethernet cable the other day. Let me check that first.
Okay.
Um, I'm going to turn off the wireless and see what happens. Are you still there?
I'm still here.
Okay, so it's correctly using the Ethernet. I
Yep.
now just can't talk to my lights, and the lights are fine.
They're not
Uh,
fine. They're gonna
so
freak out.
Keeper is saying that we're 2400 bits per second in Twitch. So what's YouTube thinking we are?
It's not saying, but it's saying YouTube is not receiving enough video to maintain smooth streaming. As such, viewers will experience buffering.
Okay, so that's a problem with the connection to YouTube and not the output from my computer.
Okay.
I'm sorry. Go to twitch.com/CosmoQuestX for a
Right. Okay.
non-buffered
All right.
experience.
Because you have fiber now, right? So you
Yeah.
can throw all the bandwidth that you need at the problem.
Yeah.
Yeah.
So this is a
Weird.
problem at the YouTube side. Or at least
Yeah.
external to my house and prior to YouTube, but not prior to Twitch.
Right. Well, I don't know. We're just going to keep an eye on it. Let us know if it glitches again. Okay. When last we saw our heroes, we were going to talk about space and/or astronomy. Your choice. Space. All right. Let me know when you're ready.
Hold on. People on Twitch are like, but we're only 720p. It's like, I can't fix that right now. You should have said something last stream when YouTube said something.
Oh, so they are downstream. So there's something
No.
about
So the
speed.
output settings for Twitch are set to 720 locally. So I was only outputting 720p to Twitch,
Right.
but they're
Right.
getting full bandwidth.
Right. At 720.
Yeah, but the 720 was set locally because I had
Yep.
both set to 720 and you were like, no, we're going to do this. We're going to do this at 1080. And so I switched it to 1080.
On YouTube.
Yeah.
Which your computer should, I mean, your computer is beefy and should be able to handle this.
Yeah.
Your bandwidth is beefy and should be able to handle this.
And it didn't happen last week and nothing has changed.
Nothing. Oh, well, yeah.
So this is definitely
Yeah.
between here and YouTube.
Yeah. Yep. All right. Well, it doesn't matter. We're going to record this locally. So,
Yeah,
you know, that'll be the
exactly.
nice quality
It will
version.
be fine. It will be fine. All right. I was in the process of opening. What was I opening? Okay, I was opening the audio. I need to start the audio file. All right. So this was not that key combo. That key combo opened in something very different. I went an audio file, not a multi-track file. What number show is this?
708.
All right. I'm ready to press record if you're ready to press record.
I am also ready to press record. I pressed record.
I have now pressed all the records. All the records are recording.
Okay. Astronomy Cast, episode 708. What goes into sample return missions from asteroids and comets? Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain. I'm the publisher of Universe Today. With me, as always, is Dr. Pamela, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I am doing well. I know that many people enjoyed Super Bowl Sunday yesterday. I am here to say I enjoyed Superb Owl Sunday. There were some science communicators that realized that Super Bowl and Superb Owl as a hashtag have the exact same letters and took it over, and there are owls. And I just want to say thank you to whatever human started that several years ago and has kept it going.
I think that's Stephen Colbert.
Really?
Yeah, I think so, if I recall correctly.
Because it's getting used by science communicators to communicate science about
Superb
owls.
Yep. I think so, if I recall that correctly.
The world needs more ninja science.
So I was having a chat with one of my patrons today, and I was asking them sort of like the content that we create and ask them how I can make things better with what I do for Universe Today.
Mm-hmm.
And they're like, I really wish there was more like topic focused, more educational content where you focused on like one topic and sort of explained it. And I'm like, have you ever heard of Astronomy Cast? This show that I do with a PhD astronomer where we pick a topic every week, and it's so funny because then I'm sure you get this as well. You talk to people who know us through Astronomy Cast, and like, I wish you guys did more on news.
Yeah.
Like both of us, all we do is we do an enormous amount of news. You do it all on Daily Space.
Yeah.
Everything you're doing over on with Cosmic Quest, I
Yeah.
do everything with Universe Today. News, and I don't know how we get across to people that we have layers, that there's more facets to what we do. So
Yes.
all I
Yes.
want to get across is that if you're listening to Astronomy Cast, that you are experiencing the tip of the content iceberg
It's
when it
true.
comes to the work that Pamela and I do across both of our media empires. For Pamela, it is like practical science done with Cosmo Quest, all of the work you're doing on Twitch, all of the other stuff that you do. For me, Universe Today, the videos that I make, the news that we do on Universe Today, it's a huge media organization,
Yeah.
and Astronomy Cast is just like our
The
hobby
smallest
compared to
fraction.
the smallest fraction of what we do. So and there's too much to talk about, but I encourage you, if you're enjoying what you're hearing with Astronomy Cast, this is just like I said, the tip of the iceberg. That's
So
it.
go to universetoday.com and cosmoquest.org.
Perfect. All right. Last week, we talked about sample return missions from the moon and Mars, but scientists have retrieved samples from other objects in the solar system, including comets and asteroids. What does it take to return a piece of rock or dust from space? And what have we learned so far? And we will talk about it in a second, but it's time for a break. And we're back. All right. So, what missions have been sent to try to retrieve samples from things in space that aren't the moon and Mars?
So we have the Genesis mission that returned particles from the sun. We have the Stardust mission that returned particles from a comet. We have Hayabusa 1 and 2 that returned very different amounts of asteroid. And then we, of course, have OSIRIS-REx. And I think I caught everything, but every time
I
I
think
think
that's it.
that,
Yep. I
yeah,
mean, we could talk
okay.
about the stuff that's in the works, and I know you're just going to have to put your fingers in your ears and la la la, I'm not listening, but I will explain the interesting sample return missions that are in the works and whether or not they will succeed or not. All right, well, let's talk about Genesis first, which is, I think, a spacecraft that sort of flew under the radar for most people. So, what was the plan with the
Yeah.
Genesis mission?
So our sun is giving off a variety of particles. There are uh dust. I mean, there happens to be a moderately good guitar player who happens to have spent his PhD working on zodiacal light, which is dust from our solar system. And so with the Genesis mission, the idea was to get some of these particles that are coming from the solar wind, to trap them in aerogel and bring those particles home so that we could, without having to deal with what went through the magnetic field of the earth and was affected too strongly by our earth's environment, grab those samples and study them. And this was an early mission for sample returns. It actually started out in 1997 with its feasibility study and was able to bring it home in 2004 when we were just baby journalists, or at least I was a baby journalist. You were more senior than I was at that point.
Like 3 years, maybe.
Yeah, yeah.
I guess when
But
when it came back, I've been a journalist for 5 years at that point.
right. So I knew about this mission because there was a while where any American Astronomical Society meeting you went to, there was someone going, "This is aerogel," and letting you touch a piece of this magical new substance they had for collecting stuff from space. Um, but yeah, this was kind of the OG sample return from beyond Earth orbit, or lunar orbit, rather.
And I think the thing that's kind of amazing with the Genesis mission was while capturing the particles worked great,
Mm-hmm.
bringing them back to Earth didn't go exactly
No,
according to plan.
but they made it work, sort of.
Right, right, right. So what happened?
Um, the the parachute didn't quite allow. Yeah, it just came in. There was
Came in fast.
litho breaking. There was litho breaking.
Right. Yeah, yeah. And there's these great pictures where you can see the sample return capsule just embedded in the sand where it landed.
Yeah,
Um, it's now
it's a
like
bit
where it
bleak.
landed was actually quite soft, and so it cushioned the fall pretty well. And when you think about it, like, it's this fairly wide sample capsule that's making its way through the atmosphere. Like, it's just going to hit terminal velocity, so it's going to hit the ground at a few hundred
Yeah,
kilometers per hour, as opposed to tens of thousands of kilometers per hour when it's flying in space.
yeah.
But still, um,
And
and so
aerogel
you would
isn't the sturdiest of substances.
now someone in the chat is saying that it wasn't aerogel. I'm just double checking that.
Um.
Yeah, I don't think it was aerogel.
Oh shit.
Yeah,
I'm looking at pictures and it looked like aerogel, so I called it aerogel. It is not aerogel.
yeah.
Okay,
Yeah, yeah,
we
it's like
just want
this
to start
weird.
this part over.
Yeah, so it had, like, an array of hexagons made of, various wafers of different materials that then
Okay.
interacted with the particles.
Boo, I lied. I didn't mean to lie. I'm sorry. I'm sorry. I guess I was seeing aerogel from the Stardust mission when I was in grad
Mhm.
school.
Yeah, yeah,
Okay,
yeah.
let's start this
So
mission
so
over. I
we
lied
don't have
a
to start it over.
lot.
Richard can do some wonderful, editing.
No, let's just start it over. We like Rich.
Okay. Alright.
So let's go back to what was the first mission.
Alright. Whoa, okay. What was the first mission? Let's talk, so Genesis was a mission that sort of flew under the radar. What was that?
So it was one of the old school missions that a lot of people just didn't really realize was happening. It started in 1997 with feasibility studies. It launched back in 2001. It flew in this weird loop de loop orbit, and it went beyond the Earth Moon environment to collect samples of particles from the sun that hadn't been affected by our environment and the magnetic fields and everything else in the Earth Moon system.
What kind of particles can you expect from the sun?
Well, this is kind of what they were looking to figure out. So we know that there is electrons, clearly cosmic rays, which are heavier atoms, and so what they were looking at is on this array of various semiconductor grade wafers, they were looking to see how these high energy particles, whatever they happen to be made of, interacted with each of these different systems. The different materials were designed to basically capture what is the energy, and allow us to understand what's going on out there.
And when we think about the solar wind, I mean, before Genesis, you would try to measure the solar wind in situ. You'd fly in space and
Mhm.
you'd detect the kinds of particles that were around you. And you're getting ions. You're
Yeah.
getting hydrogen ions mostly, almost
Yeah.
entirely, and then you're getting a few ions of other kinds of particles as well.
A lot
But
of
to actually be able
electrons.
to sure, but I mean, electrons are a very
Boring.
difficult particle to
Yeah.
capture compared to a hydrogen ion or some other particle that you're getting.
Yeah.
But then to be able to bring them back, as you said, you're detecting the energy, you're detecting the mass, you're getting a sense of just like the abundance of these different kinds of particles, and you can bring them back and study them in the lab with incredible precision.
Right.
Now, retrieving these samples didn't go exactly according to plan, did it?
No, there may have been a bit of litho breaking involved. Um,
That's my favorite term, lithobreaking, where you crash.
yeah. Yeah. So
Or
the capsule, like I said, this was kind of the OG sample return. They were learning a lot of things. Parachutes are hard. And so they made a very tiny crater. Um, and they did everything they could, actually quite local to me. So sample extraction took place at the University of Washington, which is in St. Louis. So it's named after the president, just like the state is, and has nothing to do with the state. So the samples were extracted at Washington University. Some of the hexagonal wafers that were used to collect the samples uh, broke, you might say, crumbled. They had
Mm.
a bad day, like thrown luggage, except thrown from orbit. But some of the wafers did survive, and all of this is now at the Johnson Space Center Curation Center that we talked about a lot in the last episode. It's the same place that the asteroid samples are kept, that the lunar samples are kept. And within these samples, they were able to tease out noble gases, oxygen isotopes, nitrogen isotopes, and start to get a sense of some of the other stuff that's coming from the sun.
Yeah, the original plan was it was gonna pop its parachute when it hit the atmosphere, and then they were gonna grab it with a helicopter and gently take it to a facility. Parachute didn't deploy. It only slowed down due to air resistance of the atmosphere and then just crashed into the desert. And, like,
Yeah.
fortunately, it was soft, and it's amazing how little science they actually lost. Real I guess learning that you don't need parachutes for this kind of thing. Um,
But
yeah, I mean, it
parachutes
was
are preferred.
they are preferred. They are, but they're not entirely necessary when you're just dealing with robotic spacecraft. So,
Yeah.
yeah,
Yeah.
that's an amazing thing. Um, all right, so let's move on to Stardust, which
Yes.
was the first samples of a comet.
Yes. So here is where we were introduced to a fabulous substance called aerogel. This is something that I swear every meeting from like grad school onwards that I attended, there was someone with a block of this stuff going, this is what we're using.
So, have you felt it? Have you
Yeah.
held aerogel? I never
Yeah.
have. What does
S-
it feel like?
it's sort of like someone took bubbles from a bubble bath and solidified them somehow. So it has that same density as bubbles from bubble bath,
Yeah.
but you can poke it like styrofoam. So imagine
Does
bubble
it br
bath
like it but
bubbles.
it breaks easily?
It breaks fairly easily, but
Yeah.
the idea is that dust grains from the comet hit it and are slowly slowed down, but slow down fast enough. So you want to slow them down slow enough that you don't destroy them. Because
Right.
if you slow things down too fast, that's how you break them. But it needed to slow them down before the particles got to the other side of the aerogel.
Right. Yeah, yeah.
And so it's low enough density and breaks easily enough that the dust grains going through it get slowed down and held onto and are undamaged in the process.
Hmm. That's interesting. So,
Yeah.
what was the plan with the Stardust mission?
Uh Go out, fly through the tail of a comet and come home with the sample and drop it on the planet. As one wants to. And then this is actually one of the first big fully online citizen science projects came out of this particular mission. So Stardust went out, it collected dust from Comet Wild 2. It looks like the word wild, it's actually Wild.
Mhm.
Um, and then they took images scanning through the aerogel at a variety of different focal lengths. So they were able to see different depths in focus in the images. And so citizen scientists would sit online scanning through these stacks, looking for the trails through the aerogel that pointed to where the dust grains are.
Oh,
It,
and, like, those pictures, if you get a chance, like, look up the pictures from Stardust because they look like someone dropped rocks into
yeah,
water, and you get these sort of like the bubbles that you would see as the rock is sort of plunging down into the water, and then it's just like it's a freeze frame of it stopped in the
Yeah.
aerogel at different depths.
Yeah.
It's so cool.
And it was a hard project. Like I failed to pass the tutorial. It turns out I do not have the visual acuity to notice necessarily in a field
Wow.
of gray. Yeah, yeah, I failed. I failed at a whole lot of successfulness. Um,
And that's why now you organize teams of people to
yes,
look for this stuff.
I
And
do better training. Well, no, they had excellent training materials. My eyeballs just failed.
yeah.
But understanding that you're not always going to succeed, that there are going to be humans that are better at some tasks and worse at others, and most of all, learning that the public is willing to help. This
Mm.
team had a huge project going through all of those sequences of images at different focal lengths was going to take longer than they necessarily wanted to wait to find all of those dust grains. So the
And
public was needed.
and so what did we learn about sampling a comet like this?
Use citizen scientists is the most important thing in my brain, I have to admit.
Okay, so and I can answer this then. So, I mean, one of the big questions that astronomers had was where do these comets form? How do they migrate around the solar system?
Yeah.
Do they form? Did they form close up to the sun and then migrate farther out into the solar system? And what they found was that, uh, you know, that in Kuiper-belt objects anyway, I mean, we're not talking about stuff out in the Oort cloud, but in Kuiper-belt objects, they probably formed closer into the sun in higher temperature regions and
Mhm.
then migrated outward as the sun settled down, as the planets started to form, as things got kicked out into this region outside the giant planets. And so they really are this archaeological history
Yeah.
of the formation of the solar system. And although we don't have any like proper samples of a comet, where someone actually goes and digs a hole in the sample, takes a core sample, brings it home, you're getting these really interesting insights into it. And
Yeah.
this will kind of stretch into our next conversation about the asteroid ones, because I think the theme that has sort of been in Astronomy Cast as we've been talking about this
Yeah.
is that asteroids are more comet-like than we ever thought, and
Yes.
that comets are more asteroid-like than we ever thought. And so, in fact, the lessons learned from sampling these asteroids have a lot to tell us about the inner solar system, the early solar system, as well as what we learned from comets. All right,
Yeah.
we're going to move on, but first I want to take another break. And we're back. All right, let's move into the regime of asteroid sample return missions. Who tried this crazy thing first?
Japan with Hayabusa at Itakawa.
Yeah.
Itakawa is a cashew-shaped asteroid that has fairly smooth areas, fairly rocky areas. It's got a little bit of everything if you're looking for geology. And the goal was to bring back several grams of material from the surface. Sample collection did not entirely go as one might wish.
Yeah.
By which I mean the mission brought back less than a single gram.
Hmm.
If you've ever cooked, you realize 1 gram of flour is like a it's what you kind of tap off your spoon. Yeah, it's a very small amount of material. So the sample getting, um, Hayabusa just didn't want to get its hands dirty. Is
Well, right. I mean, the thing that's interesting about this was that really their entire method of sample. I mean, they delivered a mini rover. They tried to
yeah,
deliver a mini rover to the
Minerva.
surface. That the Minerva that failed,
Yeah,
and then they tried to deploy their sample collection uh, system, and
yeah,
that failed. And I'm trying to like imagine you have a sample return capsule that you're attempting to use on your car, and but you did accidentally swipe your car against the
right.
rock that you're trying to sample, and then you bring the car home and you're like, wait a minute, there's some, so they were able to
Yeah.
recover some, as you said, tiny fraction. But like when you learn about, like, maybe this is a story all on its own, or maybe I'll have to interview somebody from behind the Hayabusa
Yeah.
mission, because that first Hayabusa mission, it was just failure after failure, problem after
Right.
problem with thrusters and with electrical systems and with the sample collection and the mini lander and all of this stuff. And yet they got it home and they
Yeah.
got the samples back down to Earth. And it is just one of the most incredible stories of recovery when just everything was going wrong. And sort of always, I feel like I have so much respect for the Japanese Space Agency and
And
how clever and innovative they are when they approach these kinds of problems.
one of the things I love about how they do missions is we are used to it either succeeded or it failed completely. And they actually grade their missions on a point system like a prof. And so this was very apparent with their recent attempt to land on the moon. It didn't entirely succeed, but they got points. And the criteria that they used to judge the success of Hayabusa was what was the ultimate result. So, were they able to operate their ion engines? Yes. Were they able to operate them for more than 1,000 hours? Yes. Did it go smoothly? No, but that wasn't part of the grading system.
Right.
It's
Yeah.
it's like when you're doing homework. It might accidentally take you 9 hours to complete a problem that should have taken
Yeah.
5 minutes, but you got there eventually.
But they did science. They were
They
able
did.
to recover. They described it as 1,500 grains of material, as you said, a fraction of a gram.
Yeah, yeah,
And I don't like how big a grain is. These things are microscopic.
yeah,
And yet they were able, in the lab here on Earth, they were able to determine that they are similar in composition to meteorites that have been found on Earth. They were able to
yeah.
measure the kinds of constituents. They were able to determine that this asteroid was once part of a larger asteroid. And I think this goes to that idea, people always say, like, oh, let's send a spacecraft to Mars because we will, like, why try to bring these samples back home for $10 billion when you could just send a spacecraft and study it there? Because the things that human beings can do in the lab here on
Right.
Earth just dwarfs whatever we could send to another world. There is real value in sample return missions. All right, let's move on to Hayabusa 2, the recapturing.
So Hayabusa 2, I love this mission because Japan took everything except for the kitchen sink and dropped it on Ryugu. And this includes what isn't officially called an anti-tank weapon but was an anti-tank
Right.
weapon. They dropped flyers that flitted and bounced and everything else. And then they managed to grab, this time, a much larger sample. They were outdone by, uh,
Some
well,
other mission which we're about to get to shortly.
yes, I.
Yeah.
But Hayabusa 2, they went through all of these dropping, flipping, flying, bombing, and then they grabbed a sample in what basically looks like a shop vac hose, for lack of a better term, their sample horn, and again brought it back to Earth. And it's how we've been learning that this object has water, that it has carbon, that it apparently has a bit of Vesta in it, probably. This is a asteroid that has seen things and experienced things and got crunched up a lot.
Mm.
And it's just, I don't know, it brings me joy.
So I think some of the things that I find most interesting with this is how many amino acids they've been finding in the sample. So there's been a ton of
Yeah,
papers that have been coming out from the Hayabusa 2 science team, like almost
yeah,
immediately. And you got this sort of rough, here's what it's made of, here's what it was probably a part of. But there's been paper after paper talking
yeah,
about all of this precursor element or molecules for life. most of the amino acids that are in the human body. There's like the 20
Yeah.
basic amino acids. Most of those have been found in samples of Ryugu, as well as dozens. I think they're like closing in on 100 different amino acids have been found in these various samples. And so it just shows you that maybe one of the real explanations for why life was able to form so quickly on Earth is just that
The building
that
blocks were
the building
built.
blocks were right there. That space wants to make the building blocks
Yeah.
of life as quickly as it can. As soon as you have these
Yeah.
these elements coming together in a radiative environment with various, the ability to make larger and larger
Yeah.
molecules, uh, chemistry just gets at it. And so it's been amazing. And I think that idea that asteroids are more comet-like, that they're volatile, so there's more stuff under the surface of
Mhm.
these asteroids. I mean, thanks to that anti-tank weapon, we really got a chance to see what's below the crust
Yeah.
of the asteroid, and it's a much more complex rubble pile than I think anybody had expected. All right, we're going to move to the last sample return mission in a second, the one that we have much more personal experience with, but it's time for another break. And we're back. All right. Let's talk about the one that we watched the rocket launch,
We
OSIRIS-REx.
did. We were actually together sitting at the side of the road next to a body of water watching it happen off in the distance on the causeway. So this is the OSIRIS-REx mission, and it went over and above. So Hayabusa 1 brought back, it didn't have a 1, just Hayabusa brought back less than 1 gram. Hayabusa 2 brought back 5.5 grams. OSIRIS-REx wanted to bring back 60 grams. That was the goal. The excess covering the lid to the sample container was 73 grams.
Yeah.
So their excess material weighed more than what they were hoping for their entire sample. Um, Unfortunately, the asteroid tried to eat the mission. So
Right.
we're very grateful that we were able to get that back. Um, OSIRIS-REx was a mission that led to the most delightful memes. So Hayabusa 2 got to Ryugu shortly before OSIRIS-REx got to Bennu. Ryugu and Bennu look very similar. They're kind of like uh, 10-sided die, vaguely shaped asteroids, and Ryugu's a bit bigger, but they're both rubble piles. And one of the first jokes was the OSIRIS-REx mission was able to see small, pebble is probably an exaggeration, but overly large sized dust grains getting flung away from the surface of Bennu. And so the first joke was that Bennu was throwing rocks at OSIRIS-REx to warn it off after seeing what happened to Ryugu.
Yeah.
The mission then orbited and orbited and orbited and tortured a lot of citizen scientists I may have been working with
Right.
how many rocks and boulders and lack of clearly cut craters covered its surface. And when the mission finally found a place, they had to like completely change the mission safety parameters because the goal was to find something that was a large, like not quite basketball court sized, but of that order, clear space for the mission to go down, grab a sample, and bring the sample back up. And they had to reduce the size that they were looking for to about 4 parking spaces
Mm.
because there was nowhere smooth on the surface of that asteroid. Itokawa had nice dusty areas that were perfectly free of debris, and we thought Bennu would have some of those. No, it didn't. And like Hayabusa, it had basically a vacuum cleaner arm. Its tag instrument that was used to go down. And the plan was touch the surface, roll the system to get dirt out, fire some nitrogen gas, blast away from the surface, and all would be well with the universe, and we would get 60 grams or so, hopefully. The reality is, It touched the surface and kept going.
Right.
Because,
Buried its nose in the
yeah,
asteroid.
yeah,
Yeah.
Bennu's the consistency of a ball pit, and it went down about 30 centimeters before
Wow.
it fired those the nitrogen gas, and spit itself away from the object. And the sample collection arm had the sample collection capsule rather had so much stuff hanging out, flying away. They had trouble closing the capsule lid. They got it
Mm.
all sorted. There was some gymnastics involved. They were able to weigh how much sample they had by looking at the change in uh, the moment of inertia of the
That's
spacecraft.
amazing.
Um, and then they brought it back to Earth. They I haven't mentioned this earlier. I'm going to mention it now because it has to be acknowledged. What all of these teams have succeeded in doing is throwing something at the Earth
Yeah.
from a distance, knowing where on the Earth it would hit, with the Earth rotating and having an atmosphere to deal with. And they were able to fling as OSIRIS-REx traveled past the Earth, as Stardust flew past the Earth, both missions going on to future missions. Their capsules, and they hit with the OSIRIS-REx sample collection capsule, Utah. The parachute did go off, not as they'd hoped, but it did go off. Everything was collected safe and sound. They scooped up the capsule, took it straight down to Johnson, where the lid refused to come off.
Yes. Yeah. Yeah. And that part of the story is so amazing that when you had all of the tools in the container, like they put it into this hermetically sealed container,
Yeah,
and then they were going to open it up and start to deal with all the samples, because you didn't want to get any contamination in
right.
there. And none of the tools that they had in the chamber would let them open up the lid. That a couple of the bolts
There were
had
two
cold welded.
fasteners. Yeah,
Yeah, had cold welded in space. And so they had to design a new tool made of high grade stainless steel, 3D, print it or however they built it. And then they had to, sterilize it, get it into the box. Then they could open up and get access to the samples. So how much did they find?
so here they were looking at over 270 grams.
Wow.
And so everyone is stupidly happy with this because they were able to, before they even got the sample capsule open, send off some of the excess material to be showcased at the Smithsonian Museum. There is material for putting in museums.
Yep.
Um, the samples getting divvied up among the different partners. Japan is a partner. We did a material swap with them we have material from Ryugu.
Yeah.
Canada has some of the sample. It's an international mission, and the rocks are going to be shipped around the world over time. By
Yeah.
rocks, I mean grains of sand and dust. But
And right now it's just too early. Like, we
yeah,
don't have the science yet. Like, the capsule container was only opened within the last month of when we're
yeah,
recording this, but
January
already
10th. It's now February
yeah,
12th.
I
So
mean, there's a breaking story we're just working on right now today that appears that the samples were in part of a world that might have been have water on it.
yes. Yeah, so
So it's crazy.
one of the we're at the wild guessing stage of how this happens.
Yeah, yeah, yeah.
And my favorite wild guess so far is the OSIRIS-REx flew all the way to another world just to discover a pocket of stuff that was thrown into space, either during the uh, dinosaur killing Chicxulub impact
Oh,
or
no.
something else. And I don't think we'll ever be able to isolate it that fine tuned. But I mean, this could be a part of our world for all we know.
Yep.
It's
Yeah.
wild. It's
Yeah,
awesome.
and so we will, like, once the science is in, we'll do another episode just talking about the science of Osiris. It'll be a whole episode all on its
Yeah, we're at
um
wild speculation stage right now. I just want to
all right.
reiterate wild speculation
Yes.
stage.
So here's the part where you have to put your fingers in your ears, and you're not going to this, Pamela, where I'm going to talk about, Pamela doesn't like to think about spacecraft that don't exist yet. She only wants to talk about things that have already happened. So The Chinese are planning a mission in 2025. They're going to do a sample return mission from an asteroid. The Japanese have their upcoming mission to Phobos, which launches in 2026, and it's going to be retrieving samples to Earth in 2031. And there's like one mission that was planned. We got the Titan Dragonfly mission, but when they chose the Titan Dragonfly, there was one other mission that was in the running for that, and that was going to be a sample return mission, probably from Rosetta.
Mm-hmm.
So that would be like the same, like 67P, the same comet that the Rosetta mission went to, and it would try to retrieve a sample and bring it back home, and it didn't make it. It was the Titan Dragon, and who can blame the the folks that decided on which one they want? But a proper cometary sample return mission is now big missing piece of our sample return. We've got cometary tail, but we need like core samples and things like that brought back from another.
And we're not going to be getting a true core sample because like that's a whole lot of mass. We just want like
something
tiny
whatever
core sample.
The equivalent of OSIRIS-REx, but gone to a comet as opposed to an asteroid. Yeah. All right, this is a long show, but thank you, Pamela.
And thank you, Fraser. And thank you to all of the patrons out there who make this show possible. Without you, Rich wouldn't be able to rescue the mistakes I make, wouldn't be able to put together everything else. Beth wouldn't be able to promote it. You are providing jobs, and JPL just had massive layoffs. And so we're grateful that you allow us to pay our science communicators. So this week I want to thank Bebop Apocalypse. I love that name, by the way. Jimmy Baragon, Ninja Nick, Jean Baptiste Lamontier, Emissary 9, Noah Albertson, Cody Ross, Gordon Young, Bougie Net, or Boogie Net, I'm not sure which, Stephen Veit, Jeanette Wink, Bore Androlevsvol, Ziggy Kemmler, Andrew Palestra, Brian Cagle, David Trogue, Ed, David, Gerald Schweitzer, Buzz Parsec, Zero Chill, Laura Kettleson, Robert Plasma, Joe Holstein, Richard Drum, Les Howard, Gordon Dewis, Adam Anise Brown, Alexis, Felix Goot, Andrew Setz, and Kim Barron. And if you too would like me to probably mispronounce your name, I'm so sorry, everyone. Please join our Patreon at, I believe it's the $10 or higher level. Thank you so
Thanks,
much.
Everyone. And we'll see you next week.
Bye-bye. And then they saved.
7:08.
Nope. Bad.
Nope, bad.
I was about to accidentally quit the wrong software. All right. Hello, Z-Zinc. Late is better than never.
And you're just in time for the question portion.
It's true. It's important.
So, John Suffield, any more news on the NASA JPL cuts and layoffs? So I have one little piece of news. So one of the big questions that I had when I interviewed Casey Dreyer from the Planetary Society for 90 minutes last week about this.
Yeah.
And one of the questions that I needed to know was, has it been like, are specific missions getting axed, or is it a trimming? And it appears that it's a trimming across the entire group.
Yeah.
So people are being laid off from many different missions.
Yeah, and a lot of support staff.
Yeah, and that's the first thing you would expect to go. Like I wouldn't be surprised if they have a dramatically lower public relations footprint, educational content, the kinds of stuff that we all thrive on.
Yeah, they'd already gotten rid of a bunch of contractors.
Yeah.
This has been in the works for a while, and the fact that part of the reason they have to do this is because we don't have an actual budget, we just have continuing resolutions, is really problematic. This is Congress's problem.
Hal McKinney asks, what is the fastest non-subatomic clump of naturally occurring matter ever observed, not from quasars and supernovae? So, like, what's the fastest chunk of thing that was found that isn't an individual particle?
I don't know. I
I'm
just
gonna
don't
guess it's gonna
know.
be grains of interstellar material found in meteorites. So
Yeah, but that's not the fastest moving that we've seen moving. We can't get like I
yeah,
mean it's probably something like the companion to a black hole. It's going to be something with an obscene orbital velocity.
right, right. But I think what Hal is asking, like, have we caught a chunk of thing as opposed to individual particles?
Oh,
I don't think so. Like, I think you don't get. I mean, are there water molecules moving at relativistic velocities? I don't think
yeah.
so. Like, cosmic rays are just protons or
But you
larger,
can
more
have
massive
things that are
ions, right?
getting you can
Iron.
have things that are getting shocked by like supernovae explosions and stuff.
But do they remain as a blob and move through space, or do they get ionized? They
I
get
mean,
turned
it
into particles?
depends. Yeah.
Yeah, I don't know. That's it. You always ask the tricky questions, Hal. Um,
I maintain it's probably something in orbit around a black hole.
yes, yeah. Lionel asks, "Is China getting any of the OSIRIS-REx samples?" I
No.
don't know.
No,
You
it
think
can't
no?
legally. There's a congressional mandate that no collaboration is allowed between US scientists and China at
Yeah,
the
but
level that US funded scientists aren't allowed to collaborate on papers with Chinese scientists on their US funding.
there are U.S. scientists that are collaborating with Chinese scientists on, say, using the FAST telescope.
Right, but they're not funded by NASA when they do that, and OSIRIS-REx is NASA funded.
Mm,
You have to have external funding to do things like that or special agreements with the NSF.
right.
It's coming down from Congress that that level of collaboration isn't
I
allowed.
mean, I know that ITAR defines being able to, like, no American
But
company
that's
can put their.
technology. This is
Yeah.
at the level of like you can't publish a paper with them if you have NASA funding.
So you can't use NASA funding, Chinese collaboration.
Yeah. This
And
is a
yeah, so NASA may not engage in any bilateral activities with China or Chinese owned companies.
yeah,
However, NASA employees can attend stuff in
conferences.
China. So you
Yeah.
can go to like the IAU General Assembly that
Yeah.
was in Beijing.
Yeah, that special exception was a pain in the ass and we're very grateful it was created.
You can use Chinese data if it's publicly available.
Yeah.
Um, wow, it's pretty restrictive.
It really, really is. There are a lot of scientists who are super
Yeah.
annoyed because there's like really cool geology and stuff in China, and you just can't do
Mm.
research on the geology there.
And I think as either they're going to deeply regret this shortly or they're going to change it because, like, it made sense when China was considered a backwater for research purposes. And you're like, who cares? But at this point, they have the largest radio
But
telescope in the world. They're building the largest steerable
it's,
radio telescope in the world. They're building a Hubble Space Telescope class observatory that they're going to be deploying into space. They're building space-based radio telescopes, and they're building some next generation gravitational wave observatories. They're
yeah.
building a giant neutrino observatory at the bottom of the ocean. So I don't know if you've noticed this, but like when I look through archive, more and more papers are just a whole bunch of Chinese names.
Yeah, it used to be that Canada was the leading producer of astronomy research by paper, and I don't think that's true anymore.
Like by population, because like it's always the US.
No, 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 no. Canada was actually in the lead.
Hmm, hmm. Yeah, and I think I saw something where China did more. They were like the second largest, maybe it was the largest now, number of papers that have come from a nation in journals is now coming from China.
Yeah,
And
I
so,
believe that.
like at a certain point, you're now cutting off your nose to spite your face. And at a certain point, you are the
recipient of your
less.
own sanctions. So the problem is that this is
Yeah,
related to sanctions and tariffs only raise the cost of goods to Americans.
yeah, yeah.
And
And in this case, the
sanctions in
cost of
this
science.
case,
Yeah,
yeah,
yeah. There's an interesting thing, like, you know, like whenever we talk about this stuff, it's always so complicated, right? Because there's all this stuff, there's all these legitimate complaints that people have
yeah,
about intellectual property issues and theft of technology and things done by the government and authoritarian regimes and all this stuff. Like, we get it,
yeah,
right? Yes, all of that plays a role in this conversation.
yeah,
And then at the same time, um, all the drones that we use are Chinese made. Like, they're the
yeah,
world's best in making drones. You're going to use drones. You're going to buy a Chinese drone. They're now rolling out electric cars around the whole world. You just more and more the kinds of technologies and stuff that people are going to want are going to be coming out of China. So one of the big restrictions was not letting China buy chips. So this is sort of a big requirement now that Chinese firms weren't able to get access to the smallest chip infrastructure. And now China is now rolling out 5 nanometer chips this year,
yeah,
which is one generation back now from 3 nanometer that's being used in Apple and things like
yeah,
that. And so by putting in all of these requirements, all it did was push China out of the global chip ecosystem. They're not buying their chips from Taiwan or from all these various countries. They're building them in home and
yeah,
are accelerating the capability of what the chips are going to do. And do you think they're going to stop at at being one generation behind, going from
no,
literally no native chip production capability to one generation behind in a decade? No, they're going to match it, and then they're going to exceed it, and then the
yeah,
best chips are going to come from China, and you're not going to be able to buy them.
yeah,
So
exactly.
yeah, yeah, it's so, like, like, it's just not simple. It's always more complicated than you think, and openness and trade is always, in my opinion, the best way to sort of help people get along with one another. And setting up these kinds of embargoes is so problematic, be it in space, being it in manufacturing, being in all this kind of stuff. It's a tricky time to try and
Yeah,
navigate this stuff.
yeah,
And you can have all of these concerns about other countries and how they deal with their populace and how they, and their policies, and think that the one strategy is going to last, but it's just not. I don't know. It's, again, having studied Mandarin Chinese now for a couple of years now, I'm having to read a lot of stuff in native content, right?
yeah, yeah,
And you just get this feeling like that there is in the West, there is this rising distrust in expertise,
yeah, there
and you
is.
don't get that feeling in China,
Yeah,
right?
it's
You
frustrating.
you yeah, 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 yeah. There is a sense of pride at scientific accomplishment,
Yeah,
which I think is it's unfortunate that because there's been like a targeted, this turned into a rant, didn't? Okay, there's been this targeted attack, an assault on expertise in the West for financial gain, that there are small groups of people who have established money to be made, who are trying to cause so dissent in our society for expertise. And yet you will, like, get on an airplane, and if you ask someone, would you like to be on the airplane that the that the that a group of experts deemed it safe, or do you want to get on the airplane that a group of experts deemed it unsafe? Which airplane would you like to get on? You like, get on the one that the experts. So we all trust expertise all the time in every facet of our lives, and yet for a lot of the places, when it's about the investments for the future, it's about improving our society, all this kind of stuff. It's about protecting our environment. All this stuff
yeah,
has been diminished in ways that are going to take decades to recover. That if you go out and you talk to people about whether global warming is a thing, about whether vaccines are important, about about what kinds of education should be taught in schools, all this kind of stuff, you get like a 50% acceptance, and
Yeah.
that does not turn into a thriving technological civilization.
No.
That turns into a small group of people that is trying their best under assault
Yeah.
in their country while they're trying to do their best. And that, it's like we've all worked on jobs where we just feel like garbage all the time because people are giving us a hard time, and it does
Yeah.
not make us want to come into work every day. And that is the state of political discourse, of scientific discourse in the West, and it is driven by moneyed interests who have profit to be made by spoiling the water. I'm
Yeah.
mixing so many analogies here, and it makes me really angry.
Yeah.
And then you look at a country like China that I have so many complaints about that country, right? Like, I'm sure people are like, yeah, but what about, yeah, I get it,
Yeah.
right? I agree. All those things. And yet they turned around 5 nanometer chips in a heartbeat because that's what you get when you shut someone out who devotes that much of their economy to science and technology and progress. Then this is the outcome. The outcome is they make the technological developments and you don't get to be a part of it anymore.
Yeah. Yeah. No,
Rant
I'm
over.
with you. Yeah.
Okay.
Do we
So
end on
Ambius is
that
saying,
note before we go someplace even sadder? Because, like, every nation sucks, but right now, some suck
yeah.
significantly more because,
I mean, did you see that Michael Mann won his lawsuit against his libel lawsuit against people who were defaming him in print for
no.
publishing? Yeah. So he had published the hockey stick curve, and
Yeah.
then people. So he's a climate change researcher,
Yeah.
and people just, you know, shit on him for years and years and years, and people wrote just worse and worse stuff in the press, and he finally held a couple of them to account and had to go through this lengthy, like 10-year long libel lawsuit, and he won. And so now one of them has to pay him $1 million. The other one has to pay him $1. But the point is that he was right, they were wrong. They were just making stuff up, and
Yeah.
so, but we
But
don't have time for that.
the emotional harm that he went through and the amount of
Oh
money
yeah.
that he spent, that $1
Yeah.
million isn't going to cover it.
Yeah, and you think
Like,
about NASA researchers and all that, and, like, you've gone through this kind of
I,
thing. I go through this
yeah.
kind of thing every day when I read the comments. You just kinda don't wanna do this anymore.
Well, so like the other night I realized that my head was in a really bad place because I was helping a 20 something that was dealing with an abusive ex who'd stolen her identity. And I was trying to cheer her up, but I was in a dark place, and so I was like, "Look, until you've been sued for $33 million and someone tries to murder you, you're fine." And
Yeah.
then I realized, "Oh, that's really an unhealthy place to be."
Yes.
And the fact that like I I helped a congresswoman deal with someone who had been sexually harassing female students across multiple institutes and generations, as well as female colleagues. And it destroyed my career in a lot of ways. Like, I
Mhm.
haven't really been able to get significant grant money since then. This is the society we live and work in.
Mhm.
And when you're dealing with anytime you say something that isn't the viewpoint that they want everyone to have. Oh, you called out sexual harassment. You're not supposed to do that because everything's supposed to be better now. It's the emotional cost of what people deal with, and what Michael Mann dealt with
Mhm.
was far more public than what I dealt with. Yes, my ass was discussed in Mashable. My tits were in BuzzFeed. But like he was on national TV
Yeah.
where everyone you went to high school with saw that. Everyone you will ever deal with for the rest of your life will know about it.
Yeah. Yeah, and you're like, is greenhouse gas emissions a problem for the planet? I don't know. Let's find out. Let's find people who have spent their lives trying to understand this and have them do research and
Yeah.
find out if it's a problem. Oh, they found that it's a problem. Boom, attack. Right? Like if you were going to ask, if you have this, it's a reasonable question to ask, are greenhouse gas emissions a problem for this planet?
Yes.
Potentially. So the only way to find out is to find scientists and have them figure this out, and then you get an outcome. And if you don't like the outcome, don't destroy the person's personal life.
Yeah.
Like, do better science. But it's way easier to just
Destroy someone.
attack people and destroy people and push and drive them out of the field than to do better science.
Well, and the side
because
effect that
you
is,
can't do better science.
well, and the side effect is then people are afraid to do that science because
Yeah, totally.
they don't want to
Yeah.
go through that.
Yeah, and you felt it. I
Yeah.
feel it every day.
Yeah.
That, we put on this positive, we just love space attitude, but there is this grinding negativity
Yeah.
that comes with attempting to educate people about
Yeah.
just like literally Saturn.
Right.
Saturn is cool,
And
and
some
then you
of
get
it
death
doesn't
threats.
some of it doesn't even make sense. Like,
No.
I will periodically get hate mail about how many abortions are going on in the US. And I'm like, what? I don't discuss that
Saturn.
anywhere.
Remember Saturn?
Yeah.
Yeah.
Yeah. Like
Yep.
I don't even understand some of the hate.
Yeah. Yep.
So,
Anyway, I think it's time to wrap this up.
yeah. Yeah.
So,
Thank you everyone who's still here.
thanks everyone.
Thank
Yeah,
you.
I hope you enjoyed the rant. Um, oh man, I'm not mad.
I
But,
am.
I know. Yeah. Yeah.
I'm very mad. I just hide
I'm not
it.
angry. You wouldn't like me when I'm angry.
No, I'm very much Bruce Banner, where he's like, I'm always angry.
Yeah.
That's,
Yeah. That was
I am
great. I
Bruce
love that.
Banner.
I love that line. That's like my favorite line from
Yeah.
Avengers. Yeah. You want to know the secret about me? I'm always angry.
Yeah.
Yeah, so good. All right. Well, thank you everybody for hanging out with us today. Thank you, Pamela, for bringing the brain as always. Thank you to, in advance, Richard and the rest of the producers and editors who are going to have to deal with this nonsense and turn it into some sort of coherent show.
Yeah.
We will see all of you next week.